Going?
Yep.
All right, so here we go with the flame test lab. And in this lab, I have a Bunsen burner, and a Bunsen burner that's burning a blue flame. It uses methane gas, and that's the color that it traditionally makes. So don't mess that up with the colors of the metals that we're gonna burn. Inside of small beakers here, I have several different metals, and this is one metal called copper, and it's a really concentrated solution, and I put some Q-tips inside of there last night, so then it would absorb a whole bunch of the copper ions. I'm gonna take copper right now, and I'm gonna put it into the flame, and then hopefully what we see is a specific wavelength of electromagnetic radiation being shown off by copper. When you see a firework that is this color, that's because it's got copper in it. What color is this one approximately?
Green.
Kind of a greenish bluish, yes? Fireworks, of course, don't have a Bunsen burner inside them. They have an explosion inside of them, but that's enough energy to excite the electrons, move them away from their nucleus, and then when they're moved away from the nucleus, then when they return to their space, they give off energy that we can see as, in this case, green light. I also took some copper, the copper solution, and added it to some ethanol. Now, ethanol is also known as ethyl alcohol, and if you go to a gas station, you can look at the gas station pump, and you'll see that it says 10% ethanol inside of your gas. Well, ethanol is very flammable, and so when I spray this bottle across the top of the Bunsen burner, we should see it burn really well, and we should see the copper color emitted as well because copper is dissolved in here. So this is the part that got me burned yesterday when I did this, so let's see if it works. Do you see the color? What color was it?
Green.
Green color. There we go.
Yeah, it was like green colors.
All right, next on our list is strontium. Strontium I also have here on a Q-tip. We still have some copper in there, but I think you'll still see the strontium even though the copper color is still going on. Give it just a second. Can you see the strontium color now? What color would you say that is?
Red.
Okay, here's the second one. It'll take it a little while.
Scarlet.
They're kind of the same.
I'm getting back to that bluish color for the Bunsen burner flame, but that is not blue.
That's red.
There's our really nice strontium flame right there. So when you see fireworks of that color, you know it's got strontium in it. I also have strontium in a spray bottle. Let's try it. So there's our strontium.
Whoa.
A little bit of excess flame right there that scares me.
I feel like I'm gonna get burned.
The next one is sodium. I believe this is the sodium. You should be able to see this one pretty clearly. What color is the sodium?
Orange snake.
All right. Sodium is one of the most popular elements in the world that's around a lot of things because of course you have sodium in your sweat and your hands, and so that's one color that you usually see when a lot of things burn. The sodium spray bottle doesn't work quite as well as the other ones. Usually it just got really messy. Let's see what I did. It just kind of sprays a stream. I don't know if I can get the sodium one to work. And this one caused me to get burned yesterday, so I might give up on the sodium one. You guys saw the color though, didn't you? All right, let's move on from there. We won't do sodium in the spray bottle, but we'll do let's do potassium next. Potassium is tough to see. This is a trickier one than the other ones. Here's the potassium flame, but give it a little while, and then you don't get confused because there's some orange in there from the sodium. You might be able to see it a little bit on the side here. When I move it in and out, maybe you see a change to the flame color. So it's not real obvious with the Q-tips. I think it works pretty good in the spray bottle. So watch the color here, and then we'll ask everybody what you see for a color. Whoa, a little bit of copper in there, yeah. But did you see the color of the potassium? There's the potassium. Whoops. A little wild there. When I read about potassium and what flame test color it's supposed to give, many times they use the word lilac colored flame. Lilac, I think, is like a light purple. Is that true? Girls, is that true? Would it be like a light purple color? Is that true? Just nod your head if you don't want to say anything. Okay, they're all saying yes, that it would be a lilac colored type thing. All right, the last one that I have is lithium. Lithium should be pretty obvious. It takes a little while for it to start, but then this is another one that is really popular in fireworks.
What's red? Are they blue? I told you
Can you see that color pretty good? This is my favorite one in the spray bottle, so if you couldn't see the color very good, here's the spray bottle. You see that one pretty good?
It's pink. That's a good name.
One more time? Yeah. Okay. No. Ooh, that was a lot. All right, so for your write-up now, the first thing that you need to do, don't move yet, but in a little bit, you'll need to go back to your desk and you'll need to find out what the wavelengths are in nanometers for each one of those colors of radiation or of pieces of electromagnetic spectrum. And then secondly, you need to write at least 3 bullet points that say why. Why do we see different colors of the spectrum when we put them into a flame or give them extra energy? So to help you out with that, here's my recorded, once again, explanation. All atoms of all of these metals that were burned have electrons. Electrons, when excited by the flame, have extra energy and move away from their normal orbital. When they crash back down, this all happens at the speed of light, so it's super fast. When they crash back down to their normal orbital, they emit energy, and that energy happens to be in the form of visible light of red, orange, yellow, green, blue, indigo, violet that we can see. Thank you.